July 1st, 2025. The night sky held its breath as astronomers across the globe recorded the interstellar wanderer known as 3I Atlas slipping silently behind the sun. To the world, it was just another comet vanishing into solar glare, one more faint traveler swallowed by the brilliance of the star that governs us all. But in the quiet hum of mission control rooms, something far stranger stirred. Logs flickered with a second signal, a faint trailing echo as if something unseen had followed 3I Atlas into the sun's burning shadow and emerged with it on the other side. The world expected disappearance, not company. Decades of cosmic surprises suddenly felt quaint compared to what had just unfolded. And in that moment, one question burned through every encrypted message, every data feed, every sleepless scientist. What exactly came out of the sun with 3I Atlas? If you're drawn to the mysteries that hide between stars, so make sure to subscribe and stay with us, because what comes next may change everything. We thought we knew about interstellar visitors. The first clues appeared in the quiet hum of archived data from Gemini North Observatory, dated October 31st, 2025, precisely when 3I Atlas was predicted to re-emerge from the solar blaze. The images, captured through the Sloan R prime band in 30-second intervals, showed a pattern no algorithm could ignore, a sudden dip in brightness. Then, in the next frame, a faint displaced cluster of pixels appeared, trailing slightly off the comet's expected path. At first it was dismissed as noise, a mere computational hiccup in the endless ocean of numbers. But then the same anomaly appeared again, independently across telescopes in Chile and California. Atlas in Chile, ZTF at Palomar. Both recorded the same eerie sequence, a perfect entry into the sun's shadow, a clean drop in signal, followed by a noisy pattern that shouldn't have been there. The automated survey systems were built to recognize the unrecognizable, to filter out cosmic rays, satellite streaks, and phantom pixels. Yet this disturbance passed every filter. The metadata left no ambiguity. Exposure times, air mass, UTC stamps, every number aligned with precision. It wasn't random. It wasn't transient. It was something deliberate, something synchronized to 3I Atlas's reappearance. And as teams began cross-checking logs, a strange silence rippled through the networks. No one claimed discovery. No one wanted to. Instead, the alert spread like static through internal emails, encrypted channels and mission reports marked for review only. NASA's Jet Propulsion Laboratory and ESA's Solar Orbiter both issued standard updates, noting the event but drawing no conclusions. Official bulletins recorded only what they could prove, the comet's coordinates, brightness, and nothing else. But the disturbance, the one that refused to fade, remained unaddressed. Without an explanation, speculation grew like wildfire. Some compared it to the mystery of Ison, the sun grazer that promised brilliance before disintegrating in a flash. Others whispered of Oumuamua, the object that came from the dark between stars in 2017, tumbling too fast and too oddly for gravity alone to explain. Oumuamua accelerated, seemingly pushed by nothing. Some said sunlight pressure. Others weren't so sure. 2 years later came Borisov, another interstellar guest. This one looked ordinary. Coma, tail, the usual spectacle. But its chemistry defied everything in the solar system. It broke apart near the sun, scattering fragments that glowed and vanished. Each time the cosmos offered a mystery, humanity walked away with only questions. And now, with 3I Atlas, those questions had returned. Sharper, closer, impossible to ignore. The images from Gemini North remained the focus. Each frame was perfect in its precision, and yet they whispered of something misaligned, something foreign. 30-second exposures captured the comet's return, and in each, the offset cluster refused to vanish. Different telescopes, different continents, different instruments, yet the same pattern. It was as if the anomaly had written its signature across the sky, daring anyone to dismiss it. Hubble and the James Webb Space Telescope added their own fragments of truth. Their deep space imaging revealed a smooth, elegant coma, and a tail stretched thin across the void, but even these majestic instruments couldn't explain the earlier flicker. Mars orbiters caught hints of brightness shifts, but lacked the resolution to confirm what ground-based observatories had seen. And through it all, one question refused to die. Was something following 3I Atlas? Or had our machines glimpsed something they were never meant to see? Across the world, data scientists and astrophysicists dove into the numbers, each chasing the ghost in their own way. Quick-look products flagged the dip in brightness. Pipelines tried to strip away artifacts. Cosmic rays? No hot pixels. No satellite reflections. None matched. What remained was too coherent to be noise, too fleeting to be real. It was the kind of puzzle that could end careers, or make them. Every anomaly was checked, rechecked, and debated in private Slack channels that read like coded confessions. Officially, there was nothing there. Unofficially, no one believed that. As the debate deepened, spectrographs were brought online, turning the faint light into data, color, wavelength, chemistry. Within minutes of the anomaly, instruments locked onto 3I Atlas and began dissecting its glow. The light shifted. Red at first, then, frame by frame, a ghostly green emerged just behind the comet's nucleus. It was subtle, almost imperceptible, but it was real. The 510 to 560 nanometer band lit up, a wavelength where diatomic carbon usually shines. Some thought it could be CO+, another ion triggered by solar heat. The problem was that it didn't behave like either. It flickered, shimmered, and then disappeared entirely. 10 minutes. That was all it gave us. 10 minutes of data, captured across 3 continents and multiple instruments, before the signal vanished as though erased. Teams at NASA, ESA, and the Minor Planet Center logged the event as a provisional spectral anomaly. No specific identification, no bold claims, just data and silence. Some researchers argued for a simple explanation, a fragment breaking away, glowing briefly before disintegrating. The others pointed to dust plumes or jets, perhaps a sunlit outburst reflecting in the green spectrum. But there was a darker idea whispered among late-night data reviews, the notion that what followed 3I Atlas wasn't debris at all. The green light, they suggested, could be something else entirely. Something active, something responding to the comet's passage rather than caused by it. Audits began. Every solar observatory was checked. SOHO's LASCO C3, sensitive to magnitude 9, found nothing unusual. Stereo's instruments, designed to track faint solar phenomena, reported no moving body. Parker Solar Probe scanned its whisper camera data, nothing but dust. Solar Orbiter's images, filtered and mosaicked, showed the sun's relentless glare but no secondary object. Ground-based coronagraphs caught nothing. It should have been the end of the story. Yet the pattern persisted across archives, its fingerprints burned into raw FITS files for anyone to see. The instruments had recorded something. The world just couldn't agree on what. By late October, the reviews were exhaustive. Every instrument log, every telemetry line, every potential artifact was analyzed and dismissed. Cosmic rays, compression ghosts, diffraction flares, each eliminated with surgical precision. The conclusion was simple: no confirmed follower, no physical body trailing the comet. But that didn't explain the anomaly itself. Why did it appear across systems, across hemispheres, across different nights? Why did it mimic motion and vanish with timing so exact it defied coincidence? 3 competing models emerged. The first treated it as a fragment, an icy shard torn loose from 3I Atlas under solar pressure. Simulations fit the data, but only barely. For that to hold, the nucleus had to be massive, over 10 trillion kilograms, enough to survive the stress of the sun's heat while shedding smaller bodies. The second theory leaned toward a dust plume, a burst of microscopic particles launched by sudden outgassing. That model fit the brief green flare and rapid dissipation, but it required perfect timing, seconds of precision at solar intensity. The third explanation was colder, more skeptical, an artifact. Instrumental noise amplified across multiple data sets by coincidence, nothing more than a statistical mirage. But even those who favored this theory struggled to dismiss the synchronization, the way each observatory's timestamp aligned as though choreographed by something unseen. Months passed. Public circulars stayed quiet. The official record noted no discovery, no anomaly worth publication. But behind the curtain, private correspondence hinted otherwise. Analysts at JPL and Neuralab kept their reviews open. A few frames, unpublicized, showed a pattern too structured to ignore, a rhythm in the light curve that pulsed just as 3I Atlas cleared the sun's limb. If it was nothing, it was a very well-organized nothing. If it was something, it meant we had witnessed an interstellar object not traveling alone,